Hello student, good morning. I am Dr. Ajay Kumar Sinha. Today I am going to discuss equilibrium constant in gaseous system. Last class I have discussed law of chemical equilibrium and equilibrium constant. Then here law of chemical equilibrium, this concept you are knowing that this rate of the reaction that is directly proportional to the concentration of reactants. As for example, A plus B is giving the product C plus D. Then this rate is directly proportional, means how much product will form, how much C plus D it will form. That is the rate of forward reaction. Then rate of forward reaction is directly proportional to the concentration of A and concentration of B. Concentration of A into concentration of B means simply that rate of forward reaction, RF you can tell, RF shortcut, rate of forward reaction, that is directly proportional to the concentration of A into concentration of B. Same way, suppose when it gets equilibrium, then that time product will give reactant. Then that time product will be have as a reactant. And reactant, what was the original? You are getting the original, that will be the product. Okay, from the product you are getting now reactant. From the products you are getting now reactants. Then in this case, rate of reverse reaction or backward reaction, RV you can tell, RV. Okay, then that is equal to now rate of backward or reverse reaction, RV you can tell, that is proportional to what? Concentration of C and into concentration of D, because from C and D A is getting. Okay, then for this reverse reaction, product is treated as reactant, and this what was the reactant in the beginning, that is the product, means C plus D will give you A and B. Correct? That's why you can write also that rate of reverse reaction is proportional to concentration of C into concentration of D. Correct? Both are proportional sign. Correct? Then you know that at equilibrium position, rate of forward reaction becomes equal to rate of backward reaction or reverse reaction. This you keep in mind. It is very, very important. Then you have written two, you can say, equation, that rate of forward reaction is proportional to A into B, product of A into product of B. Okay, and other reaction you have written, rate of reverse reaction, that is proportional to product of, you can say, product of C and product of D. Correct? Then this proportionality sign you can convert in equality. Then in the place of that proportional sign is there equal you can write, or anything constant you can write as a K1. Then it will come rate of forward reaction. Rate of forward reaction is equal to K1 into concentration of A into B. And like that way, rate of reverse reaction is equal to K2. Now suppose you have removed the proportionality sign. Then for the second reaction you can write like this, K2 into C into D. K2 into product of C into D. Okay. Then two proportionality constant you have used, K1 and K2. Then for the forward reaction, forward reaction, that is rate of forward reaction is equal to K1 into concentration of A into concentration of B, and for reverse reaction, rate of reverse reaction, that is equal to K2 into concentration of C into concentration of D. Correct? Then now important things I told you, at equilibrium both rate will be equal. Hence you can write K1 into A into B, K1 into concentration of A into concentration of B, that is equal to K2 into concentration of C into concentration of D. Correct? Then now just you cross multiplication. You can write very easily that K1 upon K2 is equal to concentration of C into concentration of D divided by concentration of A into concentration of B. Correct? Means products divided by reactants. Simple way. Products divided by reactants, that is equal to K2 upon K1. And this K2 upon K1, that is equal to K, means equilibrium constant. K, that is called equilibrium constant. K means K is equal to concentration of C into concentration of D divided by concentration of A into concentration of B. Already last class I have discussed. Then this is called actually law of mass action. This question is asked separately. And Kc, what is the equilibrium constant, that is asked separately. Then this you have derived, this you have generalized. But if you will write how many reactant was there, how many moles of reactants, how many moles of products, if you want to write, introduce, means a small a into capital A plus a small b into capital B, that is equal to a small c into capital C plus a small d into capital D. Then simply for the C power you write a small c, for the D you power you write a small d divided by A power you write a small a into power for B power write a small b. Then that is because this is talking about the equilibrium constant. Then equilibrium constant you are representing in term of concentration. That's why a small c, Kc you can write, K and a small c down. Then Kc is equal to, now you got C power C, concentration of C power C, concentration of D power D divided by concentration of A power A, small a, all our power are small, and concentration of B power small b. This is a general. Now I am going to tell about the these things. Same things you will use. Same concept you will use here. Okay, but this is for gaseous reaction. Here one thing I want to tell you, that concentration, this expression you can write in terms of concentration and also in terms of pressure. Concentration you are writing the term of C, Kc. Like that way, generally gas will exist in gas, all gas will be in a gaseous state only. Then for the gas, generally pressure term is used. Gas creates pressure. But you can tell it in the term of concentration also, mole per liter or mole per cubic meter. Correct? And that time pressure will be constant. Pressure will be bar, in bar. Suppose pressure is in bar and concentration is mole per liter. You can tell mole per cubic meter you can tell. Okay, this expression you can tell in both way. In a simple way you can understand. Just like money you can tell in rupees also. Money you can tell in pounds also, dollar also. Correct? Same situation is here. Then chemical equilibrium constant you can express in term of concentration also and in pressure also. Pressure, partial pressure, small p. That's why you can write Kc. If you are expressing in term of concentration, then you write Kc. When you are expressing in terms of pressure, then that time you write Kp. Okay? And that time pressure will be in bar, BAR. Now you can understand. One thing Kc you have understood. Now Kp, how Kc and Kp are related, that I am actually going to tell you, because that relation is very, very important, most important, and numericals will be based on this relation. That's why I am going to derive that relation. Then it is very easy to derive. If you will try to understand, if you will understand, very easily you can derive. Then here we know first main step, I am telling you, step wise you understand. Then measure only 3 steps are there. Measure 3 steps, 4th step final result you will get. Okay. Then here Kc, you know how to derive the Kc. Just now also I briefed you. Last class also I briefed. Now that's for new things. For Kp you have to focus. Kp. Then because you are going to derive the relation between Kp and Kc. Then first Kc already you are knowing. Then Kp. Then pressure, how will you derive pressure of the gas? Because reaction is the same. Yes, suppose first to take example of, I will give 2 example. The first example you understand H2 plus I2, that is equal to 2Hi. Here equal to means here sign of equilibrium. Okay. Then H2 plus I2, that is giving 2Hi, means reactants 1 mole and 1 mole, and products we are getting 2 mole. Total number of moles of reactant is 1 plus 1. Okay. And products are 2 mole. Okay. 2 mole reactants are giving 2 mole product. H2 1 mole plus I2 1 mole. Hydrogen and iodine each 1 mole, and it is giving 2 mole Hi, hydrogen iodide. This reaction you keep in mind. This is a balanced equation. Now this equation you keep in mind. Then for this Kc you know how to write. Kc is equal to now products divided by reactants. I told you now products divided by reactants. That already I told you. Then here Hi has 2 mole. Then Hi, concentration of Hi power 2. Means in big bracket you write Hi and power 2 divided by, in big bracket H2 into, in a big bracket I2. Down you write H2 into I2, and upside Hi power 2. Correct? This is the Kc. Means Kc is equal to concentration of Hi power 2 divided by concentration of A power 1. Nothing is there, means power 1. Either you write or not write power, that depends upon you. Then H, concentration of Hi power 2 divided by concentration of I2 into concentration of this concentration of Hi power 2 divided by concentration of H2 into concentration of I2. This is the Kc. Now here actually Kc you have written expression. Kp, for the Kp pressure, how will you come to know the pressure? How will you come to know the pressure equation? Then now you know that PV is equal to nRT, gas law, ideal gas law. PV is equal to nRT, small n, number of moles. R means gas constant, universal gas constant. T is temperature, okay, absolute temperature. And P is the pressure, V is the volume, correct? 5 terms are there. PV is equal to nRT. Then P is pressure, V is volume, N is equal to number of moles, R is equal to gas constant, T is equal to temperature. Then PV is equal to nRT. Then P is equal to how much? nRT divided by V. nRT divided by V. Then that is equal to N upon V RT. You can write N upon V RT. Then N upon V is equal to what? Then N upon V is equal to concentration. N upon V is equal to concentration. V is the volume. Then per volume how much N is there, number of moles, that is called concentration. Okay, that is mole per liter, mole per cubic meter, m power 3, per mole per cubic meter, mole per decimeter cube. Okay, means per liter, per decimeter, per cubic meter, how many moles are there? That is called concentration. It is represented by a small c. Then now formula became P is equal to CRT, because N upon V is equal to C means concentration. Then P is equal to CRT. This relation here you will apply. Okay. This, and one more thing you remember or should know, that pressure and concentration, pressure of the gas and concentration of the gas, both are directly related, both are proportional. Means gas pressure P is directly proportional to C. This is the here important things, don't forget. P is directly proportional to C. P is directly proportional to C. It means in the place of C, you can write P. This is important. P is directly proportional to C. Then you can write in the place of C, means in the place of concentration, you can write the term P. Okay. This is a very, very important. And P is equal to, already I told you, P is equal to CRT. P is equal to CRT. This is the second important point. Okay. P is equal to CRT. This relation don't forget. Okay. Because P is directly proportional to concentration. P is directly proportional to concentration. In the place of pressure, you can write C, or in the place of C, you can write the P. Now I am going the major second step. Okay, second important point which you should understand. Then already I have told you, you have derived that Kc is equal to concentration of Hi power 2 divided by concentration of H2 into concentration of I2. Now these are the concentration. Now if you want to write this concentration in terms of pressure, then then pressure is equal to CRT. It means if you want to, now actually you have to write the value of concentration of Hi, H2 and I2, these three in terms of pressure. Only in this expression you are going to write concentration of Hi, concentration of H2 and concentration of I2 in terms of pressure. Then how will you write? Then pressure of Hi means concentration, CRT is there, then concentration of Hi into RT. Like that way, pressure of H2 means pressure of H2 means concentration of H2 into RT. Concentration of H2 into RT. Like that way, pressure of I2 iodine, pressure of iodine is equal to concentration of I2 into RT. Very simple way. This is the only important point in this derivation. This is the only important point. Pressure is equal to all three pressure of HI, PHI we can write, P and down HI small you can write, H capital H and HI but a small, PHI, PH2, PI2, like that way you should write. Then PHI is equal to, we can say, HI concentration, in big bracket HI concentration. What you have written expression, there's same things here. PHI is equal to concentration of HI into RT, and pressure of H2 is equal to concentration of H2 into RT, and concentration of iodine I2 means that is equal to concentration of I2 into RT. Then all this term you have to replace in the Kc expression what you have written. Now you are going to write. Okay. Then here concentration of you can say in this Kp term. Now just like Kc you have written, now you write Kp. Kp is equal to, we can say, pressure of Hi power 2 divided by pressure of H2 into pressure of I2. Just like Kc you have written the Kp. Same way, Kc you have written same way here. Kp is equal to, in the place of Kc you have written Kp. The Kp is equal to PHI square, pressure of hydrogen iodide, divided by pressure of hydrogen into pressure of iodine. Correct? Now you have written this only in the pressure, you have written pressure of Hi power 2. Then pressure of Hi already you have written, pressure of Hi is equal to concentration of Hi into RT. Concentration of Hi into RT. 3 you have written, pressure of Hi is equal to what? Pressure of hydrogen is equal to what? Already written, pressure is equal to iodine. Then now this expression Kp you have written, that pressure of Hi square divided by pressure of hydrogen into pressure of iodine. Then now you write the value of this PHI, PH2, PI2 value, right? Then what you will get? Then you will get Hi power 2, because PHI square is there. PHI square is there. And PHI is equal to, you already have written Hi into RT. It means Hi square and RT square. Because square is there and all things will be a square. PHI is equal to Hi into RT. You know that PHI square is equal to what? Hi square into RT square. Same way down you will write pressure of hydrogen, PH2. Then PH2 is equal to what you will write? Concentration of hydrogen into RT. Concentration of hydrogen into RT into for PI2 what you will write? Same way. Concentration of I2 into RT. Concentration of I2 into RT. Then upside RT square was there and HI square. Down H2 is there, RT into RT. Then upside 2 RT square and here RT into RT, again RT square. Then both will be cancelled out. Upside also square, RT square, down also RT square. Both will be cancelled. Then Kp is equal to, now what we will get? Hi square divided by H2 into I2. Then you know that H2 square, that Hi square divided by H2 into I2, that is equal to Kc. Already you have written. Then this term Hi square divided by H2 into I2, that is equal to Kc. Then now it became Kp is equal to Kc, means you have written the Kp expression, and that in that Kp expression you have written the value of Phi, pH2 and Pi2 value you have introduced. That is equal to concentration into RT. Already you are knowing. Then RT square, all things will cancelled. Then you will get only Hi square divided by H2 into I2, that is equal to Kc. Then actually in this case you are getting Kp is equal to Kc. In case of H2 plus I2, that is equal to 2Hi. In this case Kp is equal to Kc. This is the main things you have derived. Kp is equal to Kc you derived, but it is not there. It is not 100% correct, but 80% it is correct. Because why I am telling? Because always that chemical reaction what you are writing will not equal, reactant and will be not equal to number of products. Number of moles of reactant will be not always equal to number of moles of product. Here 1 mole, 2 mole reactants were there, you got 2 mole product, but always it is not true. As for example, you take the synthesis of ammonia. N2 plus 3H2. N2 plus 3H2 equal to 2NH3. 2 mole of ammonia you are getting. Then reactants are 4 mole. N2 plus 3H2 means 1 mole N2, 3 mole H2. Total 4 mole. You are getting only 2 mole ammonia, 2NH3. But it is a balanced equation. N2 plus 3H2. That is equal to 2NH3. Here equal to means you should write a sign of reversibility, equilibrium sign. Okay. Then here 4 moles is becoming 2 mole. It means 4 liter you have taken this 1 liter nitrogen and 3 liter hydrogen. Total 4 liter. And you are getting only 2 mole. Means 2 liter ammonia you are getting. 1 mole nitrogen, 3 mole hydrogen. Or a liter, in the term of liter, 1 liter nitrogen and 3 liter hydrogen. Coefficient is telling about the mole or liter, both. Okay, you can understand both way. Then 1 liter hydrogen and 3 liter hydrogen. 1 liter nitrogen, 3 liter hydrogen. It is giving 2 liter ammonia. Means less volume you are getting. Means volume is decreasing. Here only you can understand very important things. Here products you are getting less than reactants. Total reactants. It means volume is decreasing. In products you are getting less volume. That's why to get the less volume, high pressure is required. High pressure is required, then volume will be less. This is a question is asked about the volume. What should be the pressure? Then this is the proof, because volume you will get, volume will decrease only, then pressure will be high. Boyle's law. Okay, Boyle's law. That's why in this synthesis high pressure is required, because volume is less, it means pressure requirement is more. Hence in this synthesis we can say pressure requirement is high, and because volume is decreasing, then volume how will it decrease? in term of temperature, then if temperature will be less, then volume will decrease if temperature will be less. Hence, in condition is there that in the synthesis of ammonia, high pressure is required and temperature is required less, not very less. Theoretically, you can tell that less temperature, less the temperature, and then volume will be less. But here, practically, what has been seen, temperature requirement is not very high, but less, moderate temperature. But pressure will be high, temperature will be moderate. Okay, neither less nor more. Practically, it has been seen. Then these extra things I have told you, 2 things. Question is asked in IIT Mains and in advance also, and every examination, because this is the technical things. All this type of things will be important. Okay. Then now this point I told you, but here Kp is equal to Kc I told you, but I am telling this always Kp is equal to not Kc, because number of moles of reactant will be not always equal to the number of products. Okay, both will differ. Then in case of synthesis of ammonia, I am telling you N2 plus 3H2, that is equal to 2NH3, means 4 moles is converting into 2 mole ammonia. Okay, reactants total 4 mole, 1 mole nitrogen, 3 mole hydrogen is giving 2 mole of ammonia, means less number of moles. Means product minus reactant, product is 2 and minus reactant is 4, 2 minus 4 minus 2, like this. Then now here what you have to understand, in this balance equation, keep in mind, now second example what I told in the beginning, this is the second example, N2 plus 3H2, that is equal to 2NH3. Now you keep in your mind this equation, this reaction. Then now Kp expression, again you write for this equation, Kp, same way, 2NH3, product is 2NH3. Then you write pressure of NH3 power 2. Pressure of NH3 power 2 divided by pressure of N2 into pressure of H2 power 3, because 3H2 is there, 3H2, hence power will go 3. Then Kp will become, what will become? Then power of this thing, pressure of NH3 power 2 divided by pressure of nitrogen into pressure of hydrogen power 3. Power 3 means down it will come total power 4. Due to the nitrogen 1 power, due to the nitrogen nothing is there, into means 1. Then power 1 and this for hydrogen 3, then down it become 4. Upside become 2. Power means pressure. Then upside power is 2 and down power is 4. Then this you keep in mind. Then this is the relation for Kp in case of ammonia, synthesis of ammonia, that Kp is equal to pressure of NH3 power 2 divided by pressure of nitrogen into pressure of hydrogen power 3. Now again here you put the same way pressure and concentration relation. Pressure and concentration relation, what you have done in case of H2 plus I2, that is equal to 2Hi, that way. Then here you will write pressure of, first write pressure of ammonia, then pressure of ammonia means concentration of ammonia into RT, concentration of ammonia into RT. But here a square is there, that's why again you write here concentration of ammonia power 2 into RT power 2, RT power 2. RT you write in bracket power 2. Okay, means on R also 2 and T also 2. Hence RT you write in bracket and power 2. Okay, and down what you will write? Then again same way you will write concentration into RT. They are into concentration into RT. Into concentration into RT, and that you can write again same way, into write in one bracket, RT you write in another bracket. Into, now you have to write, you are going to write for hydrogen. Then concentration of hydrogen into RT. But here power is 3. Hence RT power 3. RT power 3. And hydrogen is also power 3. Hydrogen also write in bracket. All things you write in bracket, ordinarily a small bracket. In case of Kp, you use only a small bracket. Only in concentration of C, big bracket. Concentration of C in big bracket. In the term of Kc, big bracket. In the term of Kp, a small bracket. Okay. Then now, this actually you have written. Then now here you see, upside power is 2 and down is total power 4. RT power 4 and upside RT power 2. Okay. And NH3 power is 2 and down 1 N2 and 3 hydrogen power 3. Okay. Then this actually here RT you just write the thing separately. Then RT power 2 and down RT power 4 total. Then down RT power 2 will remain, both will cancelled out. RT square and RT power 4, then 2 will be cancelled, then down RT2 power 2 will remain. Okay. Then what is remaining now? Then what is remaining, that is equal to Kc for ammonia. That is value for Kc. What is remaining? NH3 power 2, NH3 power 2 and down N2 into H2 power 3. Then this value actually is for Kc. Kc for ammonia. Then now see, first you have written Kp. Kp is equal to, you have written. Now that Kp, in that after cancelling all the thing, that is equal to, this Kp value is equal to now Kc into RT. Kp is equal to Kc. Kc into 1 upon RT square. 1 upon RT square, because 2 RT square was remaining. Then 1 divided by RT square. Kc into 1 upon RT square. Then 1 upon RT square you can write also RT. Upside, if you want to take it upside, then RT power minus 2 you can write. RT power minus you can write. Then now relation became Kp is equal to Kc. Kp is equal to Kc into RT power minus 2. Power minus 2 in case of ammonia. Again I am telling you, Kp is equal to Kc into RT, in bracket write a small bracket RT power minus 2. This is the relation in case of ammonia. But actually this relation will vary according to the equation. Suppose PCl5 is there, PCl3 plus it will decompose, PCl5 will decompose in PCl3 and Cl2. Okay, it gives a PCl phosphorus pentachloride. Phosphorus this thing pentachloride PCl5, it can give PCl3 plus Cl2. Then this expression depend upon the what you are considering, which reaction. Okay, according to the reaction balance reaction, this expression depends according to the reaction, which reaction you are considering. You can consider for N2O4 also decomposition for N2O4. Okay, PCl5, NH3, 2HI. Okay, you can means according to the this Kp and Kc value depends, expression depends on the which reaction you are considering. Then for general, actually how both are related, because always this number of moles of reactants and number of moles of product will vary according to the reaction. Then in general way, how will you write? Then for general, I am talking about, suppose A plus B is giving the product C plus D. Capital A plus capital B is giving the product, suppose C plus D. It may be more also. A plus capital B plus capital C plus capital, means number of reactant may be more, number of product also may be more, not only 2, not only 3. Okay, according to the, you can say what type of reactions are there. Then general reaction, you are going to write a general reaction. For general reaction, then suppose capital A and capital B, A plus B is reacting and is giving C plus D, 2 product. Just for simplicity, for easy you are considering. Then now again also you consider, suppose capital A is its number of mole is a small a, maybe 2 mole, maybe 3 mole, a small a. Like that way B, A plus B are reacting, how many B are there? Then you don't know, a small b you can write. Then A into a small a into capital A plus a small b into capital B, that is equal to suppose a small c product is giving, then a small c into capital C plus a small d into capital D. Suppose d moles, a small d number of moles are there for D. Then now for this reaction, A into A plus B into B, that is equal to C into C plus D into D. First one is a small, all are a small. Then for this reaction, what will be the, you can say Kp value, how both are related, Kp and Kc. Then what you have to write the case of, either in case of HI or NH3, same way here, in general we can write Kp is equal to Kc, Kp is equal to Kc, and into RT, Kp is equal to Kc, Kp is equal to Kc into RT in bracket, and power, product minus reactant you are writing, P minus R. P means product, R minus reactant. Number of moles of product minus number of moles of reactant. RT power means C plus a small d power added in a bracket to write power C plus D in bracket minus A plus B in bracket. C plus D in bracket means product, number of moles of product added minus number of moles of reactant you have added, means difference between the number of moles of product minus number of moles of reactant. That you can write delta n, a small n, delta n, sign of delta, you know, just like a triangle, a small triangle, delta n. Then final relation is Kp is equal to Kc, Kp is equal to Kc RT power delta n. This is the final relation. Kp is equal to Kc RT power delta n. Okay. Now I am stopping only here, and next class I will discuss some numericals. Okay, that is very, very important. Full equilibrium chapters, already you have already seen thermodynamics, all are full of numericals only. Then here we will give priority for numericals also. Okay, theory, first theory and then numericals. Because without theory you can't understand the numericals. Hence both are equally important. Okay, both are important. And now I am stopping only here, and next class again I will come with numericals. I will discuss numericals. Thank you.